I'd like to end our foray into absolute value with a mention of a very important and valuable theorem in mathematics called the triangle inequality. And in fact, I would have to rate it as maybe one of the top 10 of important theorems in mathematics. It settles a lot of issues for us in mathematics, this triangle inequality. So here's a statement of it in terms of absolute value. The absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. Now, this triangle inequality has a more general form where instead of absolute value, you're measuring the distance in a particular metric in whatever geometry you're working in. So this extends beyond just our real number system or number lines. It goes into any kind of dimension, however you're measuring distance. We're faced with a triangle inequality. All right, well, I would like to, it's pretty easy to kind of verify it for real numbers. For example, suppose that a and b were 2 and 3. The absolute value of 2 plus 3 is supposed to be less than or equal to the absolute value of 2 plus the absolute value of 3. Well, here I get 5, and an absolute value of 5 is 5. And that's less than or equal to 2 plus 3, which is 5. So actually, if and it turns out if a and b are both positive real numbers, then it's not less than, it's actually just equal to. The same would go if a and b were both negative numbers. If these are both negatives, then all those negatives are going to cancel ultimately, and it'll be equal also. But when a and b are opposite signs, then we will get a less than. So let me change this. Suppose that a was 2, but b was negative 3. So the absolute value of 2 plus negative 3 is supposed to be less than or equal to the absolute value of 2 plus the absolute value of negative 3. All right, now here 2 plus negative 3 is negative 1. And I have 2, and absolute value of negative 3 is 3. This absolute value is 1. So I end up with 1 is less than or equal to 5, which of course is true. So there we get a less than. So it turns out if the two numbers are opposite signs, you actually have a less than. Okay, so it's kind of easy to I think relate to the triangle inequality with numbers. But you could ask, well, why is this so important then? And why does it have that name triangle in it? And I think it got that name. Excuse me. I think it got that name because you can relate it to triangles, and it's sort of the mathematical version of the shortest distance between 2 points is a straight line. So I'll give you an illustration of this. And so here's a triangle, and I'll draw an obtuse triangle. This is A and B, and there's a form of mathematics called vectors. Vectors look like arrows, but they're not truly arrows. They're called a directed line segment. In other words, A is a vector, which is a line segment going in this pointed in that direction. B is a line segment this short, pointed in that direction. Well, the interpretation of addition of vectors would end up being this third side, going from here to here. So if I take A and tack onto it B, then this resultant vector is what we call A plus B. Now in the language of vectors, if it's typed, these are done in bold print or non-italicized bold print, or if you're handwriting it, these should have little arrows over it. So technically I should have little arrows over that to represent vectors. But there's a triangle where this distance, which is the direct line distance between here and here, this distance is less than the sum of these two distances. Because this is not a direct distance, direct line distance. Add these together, it's longer than going there directly. So that's what I mean by the triangle inequality is sort of the math version of the shortest distance between 2 points is a straight line. if you're wondering where vectors show up, physicists use them all the time, and because they're useful for adding forces together. For example, engineers would use them in order to, if they're measuring stress on a particular object or something, they add forces together and use vectors. All right, so that's one area where the triangle inequality shows up, but it really makes its appearance in many areas in mathematics, and like I said, it's useful for solving a lot of problems. So I like to bring it up, and we won't really apply it in this course, so it's just a little bit of an extra piece of knowledge for you.